Hello, hope you're doing well today. Gonna do some math. Actually, we're just gonna go over your homework, a few problems here, and then you guys should, if you haven't finished this homework yet, make sure you get that done first, and then there will be a test coming out here that you guys can use your notes on and try your best to figure out the problems here. Yep, the test is not going to be due till the end of the day on Thursday, so that gives you some time to work on it. Alright, but first let's talk about these couple problems that some people asked about here. Alright, so this is an interesting one here. You got a surveyor, alright, and you're trying to figure out the height of this surveying device. Okay, there's a distance d in the end here. So without reading through everything here, first, the one thing that you can recognize is that, okay, inside this lens, you have vertical angles that are forming. Okay, so you got vertical angles, and so that's one necessity there, okay, to prove that we have actual similar triangles going on. The other thing that they state here is that each pair of black dashed lines is congruent. So we have an isosceles triangle. As you see, I drew the markings on it here. The base angles are going to be equal, and that means that, well, all three angles in this bottom part and inside of this surveying device, okay, they are congruent angles. Okay, and what that means is we have similar triangles that are formed. And if we have similar triangles that are formed, we have pairs of proportional sides that are created. Alright, so let's now create a proportion to help us to figure out D. Okay, so I'm not exactly sure how the answer choices were set up, but the proportion would be, okay, one of the possible proportions would be D, okay, which is the height that we're looking for here. It's compared to the height of this triangle inside here, okay, which is labeled as 0.1 meters. Okay, so there you go, D to 0.1 meters. All right, now the triangle that we're looking at that has D, okay, is actually this triangle right here. Okay, so you want to compare it to a triangle right there, okay, which is not the whole 2 meters across. Okay, it's not the whole 0.0026 meters across. Okay, it's going to be half of that. All right, so we're going from the big triangle to the small triangle. So we're going to go 1. Okay, and I'm writing in yellow now, but let's switch back to red. 1. Okay, so it's 1 meters across here, and half of 0.0026 is 0.0023. Okay, and so that's how you would set up this one, and then from there, all you got to do is cross multiply. So 0.0023d, and we would have 1 times 0.1, which is just 0.1, and then you would just divide by 0.0023, and then that will give you the distance. All right, and then you'll have to probably round it to the nearest integer, because I don't think it's going to end up being a pretty number. So yep, let me just check it out real quick here, what that is, 0.0023. Alright, so that's about 43 is what I got for this problem. Alright, hope that helps. Let's look at this one, which is another tough problem. Okay, I'm sorry that you guys had one that was quite this tough, but it isn't so bad once you think about it a bit. Alright, so we're going to compare two triangles, FGJ and the whole thing, FHG. So what you got to do in this one, and what you always have to do, is redraw the triangles, okay, so that they are facing the same direction. So I'm going to take this small triangle and flip it around. So the short side, FJ, is actually matching up with the short side of the big one, FG. So my FJ side, okay, is going to match up like that. So we have F and then J up here, okay, and which means that G is going to be the over here. Okay, so we have FG, and draw that the best, but you know it's kind of hard to draw with the mouse here. All right, so we know that this is 18. Boom, like that. All right, and we know that FJ, okay, we don't know what FJ, but for which value of FJ? We're looking for FJ. So I'm going to call FJ X, just to, because that's what our key thing that we're trying to find is, okay? So you can also call FJ X in this shape right here, in this triangle, FGH. Okay, so now we're assuming if they are similar, then we know the sides are proportional. All right, so we would know FJ is proportional to FG. So let's make a ratio that shows that. So we have X to 18. Okay, so that's FJ compared to FG. We would also know that the bases are proportional. So we would have 18 here. Interesting is FG is in both triangles here. That's what happens when you have these triangles inside triangles. So we'd have FG is 18, and the base of this one is X plus 27. Okay, X plus 27. All right, and then the true way to solve this proportion is, this is a little bit tough algebra, and I could show you that, but you know, once you have this set up, you can, and we have multiple choice here, you can just do trial and error. You're trying to figure out which X value, okay, would make these ratios equal. So, like, let's just go ahead and go for it. So we're going to put in 9 here. So notice we have 9 to 18, okay? Now you always want to reduce those ratios if you're comparing. So 9 to 18 is 1/2. And over here on this other one, we have 18, and then 9 plus 27. 9 plus 27 is 36. So we have 18 over 36. And guess what? That's equal to 1/2. So yes, these triangles are proportional when FJ is 9. Okay, remember FJ was X. Okay, so hope that helps you on that. There's a better way to do this algebraically without choices, but that's good enough for you guys for now here. All right, and one other little review problem that I want you guys to be well aware of for your test is how to do these vertical post shadow problems here. Okay, so how to figure out the height given a shadow. All right, so first I drew the picture, okay, and this was out of an old lesson, all right. But anyhow, once you have the pictures drawn, you then want to set up a proportion, all right. So we are looking for the tower's height, so I labeled that H. So we're going to compare the height of the tower compared to the height of the post, so we have H over 2. And then we're going to compare the shadows. So you want to go back to the big one, okay. It has a 119-foot shadow. This one has a 14-inch shadow. Now, since the units are different here when you're comparing, you want to make sure to convert the units to be the same. All right, now, it doesn't really matter that the units in the other ratio are different, okay, because you're comparing feet to feet. But here it does matter because, well, if you say 119, that's 119 what compared to 14 inches. And so it would be a different meaning. You're comparing different things here. So you have to make sure the units are always the same in that particular ratio. All right, so that's basically how you would set it up. And then, of course, you do the usual cross multiplying and then dividing to solve it. So there you go. There's the cross multiplying, and you got the height as 204 feet. All right, guys. Please let me know if you have any more questions. And, yep, make sure you guys do the best you can on your test there. Like I said, the best thing that you can do is redraw the figures, or draw the figures in the first place, all right, to make sure that they are orientated correctly. And then set up the proportions and solve by cross multiplying. That's really what this is mostly about. And then make sure you guys look back at my video I posted yesterday about side similarity, side angle similarity, angle similarity. Okay, how to prove that two triangles are similar. All right, have a great day and talk to you later. Bye-bye.